Hi everybody and welcome to Linux Fundamentals Part 3. Let's begin. Welcome to Part 3 and the finale of the Linux Fundamentals module. So far, throughout the series, you have got hands-on with some fundamental concepts and used some important commands. This room is going to showcase some useful utilities and applications that you're likely to use day to day. You're also going to advance your Linux foo skills by learning about automation, package management, and service/application logging. Okay, and now let's click on completed and move on to the next task, which is deploy your Linux machine. Deploying your Linux machine. Press the green Start Machine button on the top right of this task and then scroll to the top of the page to see the deployment information like so. The IP address displayed is the address of your Linux machine that you will be logging into using SSH. Take note of this for now. Deploying the TryHackMe attack box. Looking at the top of the page, press the Start Attack Box button to deploy the TryHackMe attack box that we will be interacting with. The TryHackMe attack box is a Ubuntu Linux machine that is hosted online in the cloud and can be interacted with via your browser. You will be using this to interact with the machine that you deploy in this task. And the credentials that we are going to use is the IP address of the remote machine, the username TryHackMe, and the password TryHackMe. Okay, and now let's log into the Linux Fundamentals Part 3 machine using SSH. So we click on Start Machine, and then we click on Start Attack Box, and let's just give it a few moments. Okay, let's press Enter and open the terminal. And now let's log in using SSH. So we begin typing SSH and then TryHackMe at and then the IP address of the remote machine. So this address right here, this IP address, and we can see it down here too. So 10.10.130, let's see, 130.205, and then we press enter and we type in yes, and then we type in the password, which is also TryHackMe, so TryHackMe, and press enter. And we are now logged into the remote machine using SSH. Okay, so let's now click on completed and move on to the next task, which is terminal text editors. Throughout the series so far, we have only stored text in files using a combination of the echo command and the pipe operators, the output redirector operator and the appending operator. This isn't an efficient way to handle data when you're working with files with multiple lines and the sorts. Introducing terminal text editors. There are a few options that you can use, all with a variety of friendliness and utility. This task is going to introduce you to Nano, but also show you an alternative named Vim, which TryHackMe has a room dedicated to. Nano. It is easy to get started with Nano. To create or edit a file using Nano, we simply use Nano file name, replacing file name with the name of the file you wish to edit. Once we press enter to execute the command, Nano will launch, where we can just begin to start entering or modifying our text. You can navigate each line using the up and down arrow keys or start a new line using the enter key on your keyboard. Nano has a few features that are easy to remember and covers the most general things you would want out of a text editor, including searching for text, copying and pasting, jumping to a line number, and finding out what line number you are on. You can use these features of Nano by pressing the Control key, which is represented as an up arrow on Linux, and a corresponding letter. For example, to exit, we would want to press Ctrl and X to exit Nano. Vim. Vim is a much more advanced text editor. Whilst you're not expected to know all advanced features, it's helpful to mention it for powering up your Linux skills. Some of Vim's benefits, albeit taking a much longer time to become familiar with, includes customizable. You can modify the keyboard shortcuts to be of your choosing. Syntax highlighting. This is useful if you're writing or maintaining code, making it a popular choice for software developers. Vim works on all terminals where Nano may not be installed, and there are a lot of resources such as cheat sheets, tutorials, and the source available to you to use. TryHackMe has a room showcasing Vim if you wish to learn more about this editor. Okay, and now let's see what we need to do here. So create a file using Nano. Okay, so let's go inside the terminal, and first let's list the contents of TryHackMe's home directory with the ls command. So ls, and we only see one file called task3. Okay, now let's create a new file using Nano, and let's call the file file1. Okay, so Nano file1. And there you go. And now let's write something inside the file. Okay, so hello there. And on the next line, let's say, how are you? Okay, oops, my bad. So, how are you? Okay, and now let's save first by using the Control and S. So Control S, and now let's exit the file by using Control X, like this. Perfect. And now let's quickly check if the text we wrote in file1 was successfully saved by using the cat command. So we type in cat and then name of the file, which is file1. Press enter, and there you go. Hello, hello there, how are you? Okay, let's click on complete it. Now edit task 3 located in TryHackMe's home directory using Nano. What is the flag? Okay, so what we need to do here is type in Nano and then task 3, and we press enter. And here is our flag, but let's also edit the file. So let's write learn Linux like this, and we save with Control S and then Control X to exit. There you go. And again, let's use the cat command and see if we were able to edit the file. So cat task3, and yes, we were. So here it is, learn Linux, what we wrote, right? Perfect. Okay, so now let's copy the flag and answer the question. So there you go, copy, and we paste it inside here, and we click on submit. And now let's move on to the next task, which is general/useful utilities. Downloading files. A pretty fundamental feature of computing is the ability to transfer files. For example, you may want to download a program, a script, or even a picture. Thankfully for us, there are multiple ways in which we can retrieve these files. We're going to cover the use of wget. This command allows us to download files from the web via HTTP, as if you were accessing the file in your browser. We simply need to provide the address of the resource that we wish to download. For example, if I wanted to download a file named my file onto my machine, assuming I knew the web address, it would look something like this. Okay? Transferring files from your host, SCP. Secure copy, or SCP, is just that, a means of securely copying files. Unlike the regular CP command, this command allows you to transfer files between two computers using the SSH protocol to provide both authentication and encryption. Working on a model of source and destination, SCP allows you to copy files and directories from your current system to a remote system, and copy files and directories from a remote system to your current system, provided that we know usernames and passwords for a user on your current system and a user on the remote system. For example, let's copy an example file from our machine to a remote machine, which I have neatly laid out in the table below. With this information, let's craft our SCP command, remembering that the format of SCP is just source and destination. Okay? And now let's reverse this and lay out the syntax for using SCP to copy a file from a remote computer that we're not logged into. The command will now look like the following. Okay? Serving files from your host, web. Ubuntu machines come prepackaged with Python 3. Python helpfully provides a lightweight and easy-to-use module called HTTP server. This module turns your computer into a quick and easy web server that you can use to serve your own files, where they can be downloaded by another computer using commands such as curl and wget. Python 3's HTTP server will serve the files in the directory that you run the command, but this can be changed by providing options that can be found in the manual pages. Simply, all we need to do is run python3-m http.server to start the module. In the screenshot below, we are serving from a directory called web server, which has a single file named file. Now let's use wget to download the file using the computer's IP address and the name of the file. One flaw with this module is that you have no way of indexing, so you must know the exact name and location of the file that you wish to use. This is why I prefer to use Updog, a more advanced yet lightweight web server. But for now, let's stick to using Python's HTTP server. In the screenshot above, we can see that wget has successfully downloaded the file named file to our machine. This request is logged by simple HTTP server, much as any web server would, which I have captured in the screenshot below. Okay, and now let's see what we need to do here. So ensure you are connected to the deployed instance. Yes, we are, so we can click on complete it. Now use Python 3's HTTP server module to start a web server in the home directory of the TryHackMe user on the deployed instance. Okay, no problem. So let's go inside the terminal. And what we need to do here is just type Python 3, let's see, Python 3, and then a -m, and then http.server like this, and we press enter. Perfect. So let's click on complete it. And now let's download the file from the remote machine to our machine, or onto the TryHackMe attack box. Okay. And the name of the file, as you can see, is called .flag.txt. But first, before we do that, let's go to file and open a new tab. And now let's download the file. So for that, we are going to use the wget command. So wget, and now we type http, then colon, // and then the IP address of the remote machine. So the IP address that we see right here. So 10.10.130.205 colon, and then 8000, and then / and then .flag.txt, and we press enter. And now the file is downloaded. But just to make sure, let's check if the file was really downloaded by running the ls command. But as we can see, there is a period, or we can see that here too, a period in front of the name of the file, which means that this is a hidden file. So if we were only to run the ls command like so, we won't see the file, right? But if we add the -a argument to the ls command like so, ls and then -a, and press enter, we can now see the file, right? And all of the other hidden files here, right? Okay, and what are the contents of the file? Well, let's find out by using the cat command. So we type in cat and then dot flag dot text, and we press enter. And here we have our answer. So we have a little flag that we are going to copy, and we are going to paste right here, and we submit. Perfect. And now use Control-C to stop the Python 3 HTTP server module once you are finished. Okay, yes we are. So we can, well, we can go inside here first, of course, and then click on Control-C. And there you go. Okay, so let's click on completed and move on to the next task, which is Processes 101. Processes are the programs that are running on your machine. They're managed by the kernel, where each process will have an ID associated with it, also known as its PID. The PID increments for the order in which the process starts. For example, the 60th process will have a PID of 60. Viewing processes. We can use the friendly ps command to provide a list of the running processes as our user's session and some additional information such as its status code, the session that is running it, how much usage time of the CPU it is using, and the name of the actual program or command that is being executed. Note how in the screenshot above, the second process PS has a PID of 204, and then in the command below it, this is then incremented to 205. To see the processes run by other users and those that don't run from a session, that is system processes, we need to provide AUX to the PS command like so, PS and then followed by AUX. Note we can see a total of 5 processes. Note how we now have root and cmnatic. Another very useful command is the top command. Top gives you real-time statistics about the processes running on your system instead of a one-time view. These statistics will refresh every 10 seconds, but will also refresh when you use the arrow keys to browse the various rows. Another great command to gain insight into your system is via the top command. Managing processes. You can send signals that terminate processes. There are a variety of types of signals that correlate to exactly how cleanly the process is dealt with by the kernel. To kill a command, we can use the appropriately named kill command and the associated PID that we wish to kill. For example, to kill PID 1337, we'd use kill 1337. Below are some of the signals that we can send to a process when it is killed. Sig term, kill the process but allow it to do some cleanup tasks beforehand. Sig kill, kill the process, doesn't do any cleanup after the fact. And sig stop, stop/suspend a process. How do processes start? Let's start off by talking about namespaces. The operating system uses namespaces to ultimately split up the resources available on the computer to processes, such as CPU, RAM, and priority. Think of it as splitting your computer up into slices, similar to a cake. Processes within that slice will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process overall. Namespaces are great for security as it is a way of isolating processes from another. Only those that are in the same namespace will be able to see each other. We previously talked about how PID works, and this is where it comes into play. The process with an ID of 0 is a process that is started when the system boots. This process is systems init on Ubuntu, such as systemd, which is used to provide a way of managing users' processes and sit in between the operating system and the user. For example, once a system boots and it initializes, systemd is one of the first processes that are started. Any program or piece of software that we want to start will start as what's known as a child process of systemd. This means that it's controlled by systemd, but will run its own process, although sharing the resources from systemd, to make it easier for us to identify and the likes. Getting processes/services to start on boot. Some applications can be started on the boot of the system that we own. For example, web servers, database servers, or file transfer servers. This software is often critical and is often told to start during the boot up of the system by administrators. In this example, we're going to be telling the Apache web server to be starting Apache manually and then telling the system to launch Apache 2 on boot. Enter the use of systemctl, or system control. This command allows us to interact with the systemd process/daemon. Continuing on with our example, systemctl is an easy-to-use command that takes the following formatting. For example, to tell Apache to start up, we'll use systemctl start and then Apache 2. Seems simple enough, right? Same with if we wanted to stop Apache. We just replace the option with stop instead of start like we provided. We can do 4 options with systemctl: start, stop, enable, and disable. An introduction to backgrounding and foregrounding in Linux. Processes can run in 2 states, in the background and in the foreground. For example, commands that you run in your terminal, such as echo or things of that sort, will run in the foreground of your terminal, as it is the only command provided that hasn't been told to run in the background. Echo is a great example, as the output of echo will return to you in the foreground, but wouldn't in the background. Take the screenshot below, for example. Here we're running echo hi thm, where we expect the output to be returned to us like it is at the start. But after adding the background operator to the command, we're instead just giving the ID of the echo process rather than the actual output, as it is running in the background. This is great for commands such as copying files, because it means that we can run the command in the background and continue on with whatever further commands we wish to execute without having to wait for the file copy to finish first. We can do the exact same when executing things like scripts. Rather than relying on the background operator, we can use Ctrl-Z on your keyboard to background a process. It is also an effective way of pausing the execution of a script or command, like in the example below. This script will keep on repeating the message. This will keep on looping until I stop or suspend the process by using Ctrl-Z. Now our terminal is no longer filled up with messages until we foreground it, which we'll discuss below. Foregrounding a process. Now that we have a process running in the background, for example, our background shell script, which can be confirmed by using the psaux command, we can backpedal and bring this process back to the foreground to interact with. With our process backgrounded using either Ctrl-Z or the background operator, we can use FG to bring this back to focus like below, where we can see the FG command is being used to bring the background process back into use on the terminal, where the output of the script is now returned to us. And now let's see what we need to do here. So first, README. Okay, we've done that, so we can click on completed. If we were to launch a process where the previous ID was 300, what would the ID of this new process be? And that would be 301. And we submit. If we wanted to cleanly kill a process, what signal would we send it? And that will be sigterm. So sigterm. And we submit. Locate the process that is running on the deployed instance. What flag is given? Okay, no problem for that. We just need to go inside the terminal and type in PS and then AUX. And then we press enter. And let's take a look. Oh, here is our flag right here. So let's copy that and paste it right here like this and submit. Okay, what command would we use to stop the service my service? And that will be systemctl stop my service. So systemctl and then stop my service, and we submit. And what command would we use to start the same service on the boot up of the system? And that will be systemctl and then enable my service. So systemctl ctl and then enable my service like this, and we submit. Perfect. And what command would be used to bring a previously backgrounded process back to the foreground? And that will be fg. And we submit, and now we can move on to the next task, which is maintaining your system automation. Users may want to schedule a certain action or task to take place after the system has booted. Take, for example, running commands, backing up files, or launching your favorite programs on, such as Spotify or Google Chrome. We're going to be talking about the cron process, but more specifically, how we can interact with it via the use of cron tabs. Cron tab is one of the processes that is started during boot, which is responsible for facilitating and managing cron jobs. A cron tab is simply a special file with formatting that is recognized by the cron process to execute each line step by step. Cron tabs require 6 specific values. So what minute to execute at, what hour to execute at, what day of the month to execute at, what month of the year to execute at, what day of the week to execute at, and the actual command that will be executed. Let's use the example of backing up files. You may wish to back up CMnatics documents every 12 hours. We would use the following formatting. Okay? An interesting feature of cron tabs is that these also support the wildcard or asterisk. If we don't wish to provide a value for that specific field, for example, we don't care what month, day, or year it is executed, only that it is executed every 12 hours, we simply just place an asterisk. This can be confusing to begin with, which is why there are some great resources such as the online cron tab generator that allows you to use a friendly application to generate your formatting for you, as well as the site Cron Guru. Cron tabs can be edited by using cron tab-e, where you can select an editor such as Nano to edit your cron tab. Okay, and now let's see what we need to do here. So ensure you are connected to the deployed instance and look at the running cron tabs. Okay, so what we can do here is just type in cron, cron tab and then -e, and we press enter, and we can scroll down and we can see that we have one cron tab, right? Okay, so let's click on complete it. And now, when will the cron tab on the deployed instance run? And we can see that this cron tab runs at reboot of the system. Okay, so we can just type in at reboot. Oops, my bad. Reboot, like this. Okay, and we submit, and we can exit right here. So we click on Control X. Let me try again. Control X. There you go. And let's move on to the next task, which is maintaining your system, package management. When developers wish to submit software to the community, they will submit it to an apt repository. If approved, their programs and tools will be released into the wild. Two of the most redeeming features of Linux shine to light here: user accessibility and the merit of open source tools. When using the ls command on a Ubuntu 20.04 Linux machine, these files serve as the gateway/registry. Whilst operating system vendors will maintain their own repositories, you can also add community repositories to your list. This allows you to extend the capabilities of your OS. Additional repositories can be added by using the add apt repository command or by listing another provider. For example, some vendors will have a repository that is closer to their geographical location. Managing your repositories, adding and removing. Normally, we use the apt command to install software onto our Ubuntu system. The apt command is a part of the package management software, also named apt. Apt contains a whole suite of tools that allows us to manage the packages and sources of our software and to install or remove software at the same time. One method of adding repositories is to use the add apt repository command we illustrated above, but we're going to walk through adding and removing a repository manually. Whilst you can install software through the use of package installers such as dpkg, the benefits of apt means that whenever we update our system, the repository that contains the pieces of software that we add also gets checked for updates. In this example, we're going to add the text editor Sublime Text to our Ubuntu machine as a repository, as it is not a part of the default Ubuntu repositories. When adding software, the integrity of what we download is guaranteed by the use of what is called GPG, or New Privacy Guard keys. These keys are essentially a safety check from the developers saying, here's our software. If the keys do not match up to what your system trusts and what developers used, then the software will not be downloaded. So to start, we need to add the GPG key for the developers of Sublime Text 3. Note that TryHackMe instances do not have internet access, and so we are not expecting you to add this to the machine that you deploy, as it would fail. First, let's download the GPG key and use apt key to trust it. Next, now that we have added this key to our trusted list, we can add Sublime Text 3's repository to our apt sources list. A good practice is to have a separate file for every different community/third-party repository that we add. Next, let's create a file named sublimetext.list in the directory we see on the screen and enter the repository information like so. Next, now use Nano or a text editor of your choice to add and save the Sublime Text repository into this newly created file. After we have added this entry, we need to update apt to recognize this new entry. This is done using the apt update command. Once successfully updated, we can now proceed to install the software that we have trusted and add it to apt using apt install Sublime Text. Removing packages is as easy as reversing. This process is done by using the command that we see on the screen or by manually deleting the file that we previously added to. Once removed, we can use apt remove and the name of the software, for example, apt remove Sublime Text. And let's see what we need to do here. So, since TryHackMe instances do not have an internet connection, this task only requires you to read through the material. So we can just click on complete it here and move on to the next task, which is maintaining your system. Logs. We briefly touched upon log files and where they can be found in Linux Fundamentals Part 1. However, let's quickly recap. Located in the var log directory, these files and folders contain logging information for applications and services running on your system. The operating system has become pretty good at automatically managing these logs in a process that is known as rotating. I have highlighted some logs from 3 services running on a Ubuntu machine: an Apache 2 web server, logs for the fail to ban service, which is used to monitor attempted brute forces, for example, and the UFW service, which is used as a firewall. UFW stands for uncomplicated firewall. These services and logs are a great way in monitoring the health of your system and protecting it. Not only that, but the logs for services such as a web server contain information about every single request, allowing developers or administrators to diagnose performance issues or investigate an intruder's activity. For example, the 2 types of log files below that are of interest: access log and error log. There are, of course, logs that store information about how the OS is running itself and actions that are performed by users, such as authentication attempts. And now let's see what we need to do here. So look for the Apache 2 logs on the deployable Linux machine. So what we need to do here is type cd and then / and then var / and then logs. And then we press enter and we can use, let me see, I spelled something wrong. Yes, of course. So let's try again, cd and then / and then var and then / and then log, not logs. So enter, Perfect. And now we can use the ls command. There you go. And here is the Apache 2 logs. So we can click on complete it. And now, what is the IP address of the user who visited the site? Okay, for that, we can use the cd command again. So cd and then Apache 2. My bad. Let me try again like this. Apache 2, and then we press enter. And then we can use the ls command. And now, we have permission to read the access.log.1 file. And also write to and execute it. And we can see that by using the -l switch with the ls command. So let me show you. So ls and then -l. And there you go. So we can see it right here. So we can write to it, we can, read it, write to it, and execute it, right? And same goes for the error.log.2.gz file, right? But we're only interested in the access.log.1 file. Okay, so now you know that. Let's find out what the IP address is of the user who visited the site. So for that, we are going to use the cat command. So cat and then the name of the file here, the access.log.1 file. So access.log.1 and we press enter. And the IP address is right here. So let's copy the IP address and paste it right here and click on submit and answer the final question here. So what file did they access? And the file that they accessed was this one right here, an image, JPG file, right? So let's copy that and paste it right here and submit. And move on to the final task, which is conclusions and summaries. Welcome to the end of the Linux Fundamentals module. Your familiarity with Linux will improve as you get to interact with it over time. Linux has the potential to do very powerful things with relative ease, as you have hopefully discovered throughout this module. To recap, this room introduced you to the following topics: using terminal text editors, general utilities such as downloading and serving contents using a Python web server, a look into processes, and maintaining and automating your system by the use of cron tabs, package management, and reviewing logs. Continue your learning in some other TryHackMe rooms that are dedicated to Linux tools or utilities. Okay, now let's terminate the machine deployed in this room from task 2. No problem. So we can just log out here and press enter. There you go. And close everything. We can close the whole terminal like this, and we terminate, and then we terminate here too. And now we can click on complete it. And now continue your learning in other Linux dedicated rooms. Okay, so we click on complete it here too. And we are done with this room. Okay, everybody, thank you so much for watching. If you enjoyed the video and found it helpful, I would really appreciate it if you give it a thumbs up. And of course, make sure to subscribe to the channel for more videos on TryHackMe. Okay, everybody, talk to you next time.